Yes, it is. Yes, ma'am. Sorry.
That's okay.
Can
Do
you send me the PDF? Because it is not coming up as a PDF on my site.
It's not the one that I sent you,
Yes, ma'am.
the one that I
It's only a
posted.
link. Yes.
Hmm. Just a moment. I'm gonna. Okay. Well, let's look at something that'll show where we're going. If we have the integral of 4x minus 1 over x plus 3, x minus 2 dx. We're going to do something called partial. How about partial? Oh, yeah. Fraction decomposition. And it's really not that bad. So we're going to take just the integrand. I'm going to take 4x minus 1 over x plus 3 times x minus 2. And we're going to write that as the sum of two fractions, x plus 3 in one denominator, x minus 2 in the other, a, b. And now, because we love fractions, what do we need to multiply x plus 3 by to get a common denominator? Good. And similarly, x minus 2 is multiplied by x plus 3, numerator and denominator. And then because this is an equation, we can ignore the denominators completely. So we've got 4x minus 1 equals ax minus 2a plus bx plus 3b. And here's the most enjoyable part of all. Let's combine the x's. So let's see, we've got a plus bx on the right side and 4x on the left, minus 1 for a constant on the left, and on the right, we've got negative 2a plus 3b. So let's make two equations. We'll have 4 equals a plus b. And since these are both, no, actually, let's leave it. And negative 1 is equal to negative 2a plus 3b. Well, elimination is a really nice way to solve these two equations because we can multiply the first equation by 2 and eliminate the a's. Moment, por favor. Here we go. So now we have 8 equals 2a plus 2b, and we're going to add that to -1 equals -2a plus 3b. And what do we get when we add those? Isn't this 5b? And 7. So we get that b is equal to 7/5. But we knew that a plus b is equal to 4. So we've got a plus b equals 4. A plus 7/5 is equal to 4/1 times 5/5. Why did I do that? Why did I do that? Yes, very good. Thanks, Justine. So we've got a plus 7/5 is equal to 20/5. And if I subtract 7/5 from both sides, I get that a is equal to 13/5. Those numbers seem weird, but let's go back to our original question, because now we can rewrite this integrand as 13/5 divided by x plus 3 plus 7/5 divided by x minus 2. And let's see what that looks like. What do you notice about these integrals? What pattern are they? Give us some more room. So we've got 13/5 natural log of x plus 3 plus 7/5 natural log of x minus 2. Let's see. So partial fraction decomposition really capitalizes on u over du over u, the natural log. And that's why we focus on it so much. So I'm going to add a question to the assignment. So this will be question 14. And I want you to find the integral six x minus 4 times x minus 5 x plus 4 dx. And you're going to solve using partial fractions. I think I'm also going to add another try this. So this will be try this 4, and it'll have an answer. X minus 11 over x minus 6 x plus 3 dx. So let's set this one up. The two fractions, so we're just going to take the integrand. We've got x minus 11 over x minus 6 times x plus 3. And that's a over the first denominator, x minus 6, plus b over the second, x plus 3. And then we get a common denominator. So I'm going to multiply the first fraction by x plus 3 over x plus 3. And the second by x minus 6 over x minus 6. So that we have a times x plus 3 x minus 6 x plus 3 plus b over x plus 3 x minus 6 is equal to x minus 11 over x minus 6 x plus 3. And do you see that because it's an equation, as long as we make sure not to include -3 or +6 in our answers, we can just ignore that whole denominator. And we've got x minus 11 equals ax plus 3a plus bx minus 6b. We're going to do the same thing again. Let's gather the x's. And the constants. And you notice that we're not using x, we're using the coefficients of x. So our first equation is 1 equals a plus b. The second equation is -11 equals 3a minus 6b. I can multiply the first equation through by -3 or +6. -3 will get rid of the A's. +6 will get rid of the B's. And B is feeling left out. Let's go ahead and eliminate the B's by multiplying by 6. So that we have 6 equals 6A plus 6B. And we're adding that to -11 equals 3A minus 6B. The B's go away. 6 minus 11 is -5. 6A plus 3A is 9A. So that we get that A is equal to -5/9. Our first equation was A plus B equals 1. So let's write 1/1 times 9/9 equals -5/9 plus B. So we're going to add 5/9 to both sides. 5 plus 9 is 14. So we get that 14/9 is B. And now this, what would have been a pretty frustrating integral, is just -5/9 x minus 6 plus 14/9 x plus 3. And we can write the answer out really without any thought. -5/9 natural log of x minus 6 plus 14/9 natural log x plus 3 plus c. Does that make sense? Okay. I noticed that several students had to leave. I just see their messages. So let's do one more example. I'm going to stop and start.